Today I'm going to talk about LeetCode question number 695, max area of island. You're given an m by n binary matrix grid. An island is a group of ones, representing land, connected four directionally, horizontal or vertical, not diagonal. You may assume all four edges of the grid are surrounded by water. So this means outside of the grid, this is all water here. It's not land. Return a maximum area of an island in grid. If there's no island, return 0. So what does maximum area mean? So basically we count how many squares in a grid constitute that island. And that's basically the area of the island. So for example here, this island's area is 1, this island's area is 4, this one is 5, etc. So how do we go about this? This problem is very similar to that of LeetCode question max or number of islands. LeetCode question number of islands, but with a slight twist in that we have to count the area, how many cells constitute an island here. Okay, so basically our approach is we're going to use DFS graph to whenever we encounter an island. So let's say we counted this island here, we're going to do DFS on it in order to get all the adjacent islands that's connected four directionally to it. Okay, so like this here, and then we do DFS on this to get the four directionally connected islands like this, and then this, and etc. And we continue until we don't see an island, until all the islands until all the land masses in this island are visited. Okay, and while we're going through this, say if we're here, say we were here at first, and then through DFS we got to here. But we don't want to double count this, okay, in the area. So what we do is before we conduct DFS on this and to get to the adjacent land masses, we mark this as visited already. How do we do that? Well, this grid only consists of zeros and ones, so we can simply, assign it to a value of 2. And that way we know it's marked as visited. And when we're doing the DFS on this cell here, it can focus on unvisited parts of the island. Okay, so basically as we're going through DFS, we're going to count the number of nodes, or a number of land masses that's the landmass itself, and any ones connected four directionally, and then we should be able to get the area of that island and check to see if it's a maximum area, if it's the most maximum area we found so far. Okay, for example, if we do DFS on this island, eventually they're all going to turn into 2, and as we iterate through the array, since they're already marked as 2, they're already marked as this island being visited, so we don't do double work on doing DFS on this again. Okay, and the runtime is O of m by n, and yeah, that's how we're gonna go about it. So now to code this up, so what I'm first going to initialize is my result variable. Initially it's going to be area of 0. I'll name it better to max area. Initially it's going to be 0. And then just to make it easier for me, I'm going to initialize total rows of the grid and total columns of the grid. Okay, and then I'm going to iterate through the entire grid here, and if we encounter a 1, that means that's an island that's unvisited, so let's count the area of that island, and while we're counting, we're going to mark those land masses as 2, just to make sure, just to mark that we have already visited them, don't visit them again, and yeah, then we're going to finally return the area and assign it to our max area if it's bigger. Okay, so for I in range rows for j in range total calls if grid at I and j is equal to 1. That means that this is an island that we haven't visited before. So max area is going to be equal to the max of itself. And the result we get from performing depth first search on the island. So I and j, and finally we'll return max area. Okay, so now let's define this helper here. Helper is going to take row and column positions. And what are our base cases here? So first we want to check row and column aren't out of bound of the grids. We don't want to index out of bound error. So if row less than 0 or column less than 0, return 0. Okay, why do we return 0? Because we're calculating the area here. And if the grid is out of bounds, this doesn't count as an extra area we should when we're calculating the area of our island here. Okay, so we return 0 if row greater than or greater than or equal to total rows or column is greater than or equal to total columns, return 0. Do not count this as an area that we should count towards the final area. And also if grid at the position row and column is not equal to 1, and if it's not equal to 1, that means it's either water or we've already visited that node, so don't double count it. And we return 0 again. Okay. Now I'm going to initialize my total area variable here. So if grid at row and column is equal to 1, that means it's a landmass that we haven't visited yet. So total area plus equals 1, obviously, because we just found a cell that represents an island, so we want to add it to our total area count, and then make this, mark this as 2, meaning, hey, we visited this cell already, this landmass already, don't count it again. And then finally, total area is going to be equal to, I'm going to call this function 4 times for each direction, up, down, left, right. Oops. So this is going to count as left. And right. And up and down. Okay. So if we are at this cell currently, then total area is now 1, and we mark this as 2, and now we're going to explore the total area of the cell below it, which if we do that, recursively, it's going to start back up here, and I'm sorry, turn total area, and yeah, so it's going to come here. We're not going to explore back up here because it's marked as already visited. So we're going to calculate the total. We've incremented total area here. and then we're gonna explore here and here, and eventually this area. And this part of the island here, it's not going to have anywhere to visit, so we're going to hit one of our base cases, and eventually, since tool area is incremented by 1, we're going to return 1, and then this one will be incremented to, and then we're going to go back to the recursion stack, call stack, and then we're going to go back to this guy. That 1 is going to be incremented to this guy's tool area, and then the 2, so 1 plus 1 total area plus return value here. It's going to make 2, and then that 2 is going to be returned here, and that will make it 3, and then it's going to return here and make it 4, and yeah, and then finally we'll get 4 for the total area. Okay, so I think this is it. Let me try running it. Okay, it works, and I'll submit. Okay, great, thanks for watching.